Hello everyone, welcome back to Pi Theory. In this video, we are continuing our NEET 2025 paper solving series. Yeah, we have already posted the part 1 of it where we have solved the question number 1 to 25 of the NEET 2025 paper. Okay, so let's start again with the question number 26. Let's see what is question number 26. Here we are having, what is it? A parallel plate capacitor made of circular plates is being charged such that surface charge density on its plates is increasing at a constant rate with the time. The magnetic field arising due to displacement current is what? Okay, options are given. Zero at all places, constant between the plates, zero outside the plates, non-zero everywhere, with maxima the imaginary cylindrical surface connecting peripheries of the plates, and zero between the plates. Which one of this will be? Okay, so this is actually a multi-concept questions where we are actually connecting, not even multi-concept, like three or more concepts we are going to assimilate in this. Okay, so what and all are those? The capacitor concept, right? The magnetic field due to current carrying conductors we are connecting, the ampere circuital law basically we apply, and also the displacement current, right? So these concepts we are actually trying to assimilate in this. So let's see quickly how actually we can solve this. In simple terms, first let's consider how to find the displacement current. How to find the displacement current? If suppose we have a parallel plate capacitor, we know the charge capacitance potential relation for this. Q is equal to what? CV relation that we are having, right? Displacement current, we have the relation, right? Displacement current, you can write it as equal to what? dq by dt. At what rate the charge on the capacitor plates is changing, you can actually write. So basically here, you can write the displacement current dq by dt, that will be equal to what? C into what? dv by dt, right? But for a parallel plate capacitor, you know the potential relation, what it is. If E is the electric field and D is the separation between them, we know you can write it as what? V is equal to ED, we can actually write. So obviously this relation becomes, and obviously this electric field also. What is electric field? If sigma is the surface charge density, right? This is plus sigma, this is minus sigma. If you are going to take, you can write this as what? Sigma by epsilon zero. This I have taken directly from the potential chapter, right? So E is equal to sigma by epsilon zero. So obviously this relation becomes what? C into d by dt of sigma by epsilon zero, correct? C I have written, and D is also there. V is nothing but E into D. Correct. So here what will happen? This D and epsilon zero, if we is a constant basically. So you can write what? C into D by epsilon zero, D sigma by dt. Right. Now, what is it given in the question? You can see here the charge density is increasing at a constant rate with the time. That means d sigma by dt, this is also a constant. Or in general, you can write the displacement current is basically a constant current. Now, our problem simplifies basically into this. If suppose we have a current carrying conductor, right? So I'm making an analogy here. If suppose we have a current carrying conductor through which we have a constant current that is flowing, the magnetic field due to this, right? See, we have the relation. This is basically directly from the NCRT, coming as the application of Ampere's circuital law. The magnetic field, see, at a distance r from this, if you are taking, we have B is equal to what? Mu naught I divided by 2 pi r. But what is the magnetic field inside? We can find that one also, right? See, inside, if the current is uniformly distributed throughout, the magnetic field inside, how do you find? You apply Ampere's circuital law here, right? Finding the unit current per unit area you apply and find the current through that area that you are specifying. So in that, the magnetic field relation you are deriving, how much is that? Equal to mu naught I r divided by 2 pi capital R square, where R is the radius of this wire you can actually take. So this relation is what we are using here, okay, where we have the parallel plate capacitor once again, if you see, okay, and this displacement current, you say it is uniformly distributed throughout, right? So what will happen? Obviously, at a distance r, if you are taking, the magnetic field will be given by what? Mu naught id, where id is the displacement current, into r divided by 2 pi r square, where r is the area of the parallel plate capacitor, you can tell. Okay, now what will be the situation here? See, this relation actually tells from the surface of the conductor, the first relation, from the surface of the conductor, the magnetic field is inversely proportional to r, but this is telling what? B is proportional to what? R. Right. So what we are seeing from the center, if you go to the imaginary surface of this cylindrical region that you are considering, magnetic field will be increasing. correct? Magnetic field increases. It will be maximum at that surface that we'll be getting, and thereafter it will decrease. So obviously, which will be the answer that will be connecting here? So you'll be getting option number 3 only here, where you have non-zero everywhere with maximum at the imaginary cylindrical surface connecting peripheries of the plate. That will be the answer for this. All right, everyone, here we go for the question number 27. An unpolarized light beam is traveling in air is incident on a medium of refractive index 1.7773 at Brewster's angle. So what is that thing? We have a medium of 1.73 refractive index, and here we are having air. So mu is equal to 1 L. Okay. Now the point it is given, this angle at which it is falling, it is the Brewster's angle, or it is the angle of polarization, right? So that we mark it as what? Theta P. Let's mark. So which of this is correct? Reflected light is completely polarized and the angle of reflection is close to 60°. Reflected light is partially polarized and the angle of reflection is close to 30°. Both reflected and transmitted lights are partially polarized with the angle of reflection and refraction close to 60° and 30° respectively. Transmitted light is completely polarized with angle of refraction close to 30°. This is a very simple question, correct? What is that thing? We apply the concept of polarization due to reflection. Very clear, correct? Seeing this only we can tell the Brewster's angle, angular polarization, we can easily connect to, correct? What is that thing? If a light ray is falling from a medium onto another medium and the angle of incidence is equal to Brewster's angle, okay, that is the angular polarization. What will be happening? The reflected light will be completely polarized, correct? So that's the basic thing we need to see, correct? The reflected light will be completely polarized, not partially polarized. So very clearly, it is answer is nothing but option number 1 only. Correct. Reflected light is completely polarized. Why did I choose this? Because second one you can see it is partially polarized. It is told, so it is wrong. And the third one, what it is, reflected and transmitted light are partially polarized. Is that perfectly polarized? Is that correct? No, because transmitted light is partially polarized. Reflected light is completely polarized. Okay, so option 3 is also wrong. What about 4? Transmitted light is completely polarized. Wrong, it is partially polarized. So it is option number 1 only, easily we can take. So let's continue this and see what will be the angle of reflection also. What will be the angle of reflection? Angle of reflection by loss of reflection, you can tell this will also be what? This angle of incidence only. That is the angle of polarization. What is the relation for that? We have tan theta p. What is that equal to? Mu. Correct. This is a very clear relation for what? The angular polarization of Brewster's law. We can actually tell. So what will be tan theta p? Here it is given as what? 1.73. Correct. 1.73. But 1.73 you can write it also is equal to what? Root 3. So theta p will be obviously what? 60°. That will be your answer. Here we go for question number 28. What is it? Two identical charged conducting spheres A and B have their centers separated by a certain distance. What is that? You have two spheres A and B. Their centers are separated by a certain distance. This is A and B. Charge on each is Q, correct? And the force of repulsion between them is F, obviously. Yeah, they repel each other with a force F. Obviously, we can write here this relation also. What will that be? KQ square divided by R square. Good. A third identical uncharged conducting sphere is brought in contact with the sphere A first and then with the B and finally removed from both. New force or repulsion between charged spheres A and B. How much is it the question? Radii of A and B are negligible compared to the distance of separation so that for calculating force between them, they can be considered as point charges. Okay, this force of repulsion between them, new force of repulsion between them, how much it is? Correct. The simplest idea that we apply here, what it is, two identical charges, right? Suppose this is of charge Q1 and this is of charge Q2. All right. If they are identical charges, identical conducting charges, if they are placed in contact if they are placed in contact, what will happen? Charge separation will be happening. From that, having more charge, charge will flow to that of that is having low charge. And what will be the final charge on both? It will be the average you can actually take, which will be nothing but what? Q1 plus Q2 by 2. That will be the charge on both. Correct. So here, if you are taking A, which has charge Q, you place this in contact with what? Yeah, you place this in contact with C, correct? Whose charge is actually what? 0, correct? So the average when you're taking the charge on both become how much? Q by 2 and Q by 2. Now what you are doing? You are taking this same thing again. You have this B, correct? Who is having charge Q, correct? Now you are placing this in contact with what? C, whose charge on it is now how what? Q by 2. So the charge on this both becomes what? You have to take average of q and q by 2. So this becomes q plus q by 2 divided by 2. How much is that? 2q plus q, 3q by 2 by 2. You will be getting what? 3q by 4. That will be the charge on both now it will become. So what is it? You have A and B now separated by same distance R we are taking. This is Q by 2 and this is how much? 3Q by 4. So they repel each other. You can find now the how much is the force of repulsion between them, right? These two forces will be equal and opposite. So the new force, how do you find? You can write F dash. How much is that? Equal to K into, what are the two charges? Q by 2 into 3Q by 4 divided by R square. Okay, so what will be happening here? K q square by r square I took common outside, right? And you can write that as F obviously. And this will be like what? 3 by 8 it will be coming, correct? So this K q by r square is nothing but what? F only. So you'll be getting what? F into 3 by 8. So you'll be getting the answer what? F dash, that will be equal to what? 3 by 8 F. That will be the final answer for this. What is the new force of repulsion between them? It is option number 4, which is 3F by 8. That will be the answer. Right, here is question number 29. A container has two chambers of volumes V1 is equal to 2 liter and V2 is equal to 3 liters separated by a partition made of a thermal insulator. The chambers contains N1 is equal to 5 and N2 is equal to 4 moles of ideal gas at pressures P1 is equal to 1 atm and P2 is equal to 2 atm respectively. When the partition is removed, the mixture attains an equilibrium pressure of. Correct. What is that we can apply in this case? See, we apply the ideal gas equation only basically. What is our ideal gas equation? We have PV is equal to what? nRT, where P is the pressure, V is the volume, N is the number of moles, R is the universal gas constant, T is the temperature. Okay, see in this question, the temperature is not being discussed about, correct? So here we assume that temperature is constant. Let's assume that temperature is constant here. Okay, and we have so the initial number of moles is given. How much is that? Equal to 5. N2 is equal to 4 moles. Now, if these two are mixed, see here we have two chambers, right? What are the volumes? Here, 2 liters of volume here, 3 liters of volume here. Now, if the partition is removed, the final system, if you are taking total number of moles, you can write it as equal to what? N1 plus N2, correct? N1 and N2 you are having. Finally, when the chamber, this is removed, the partition, if it is removed, total number of moles, how much it is? Here it is N1, here it is N2. Finally, what will be N1 plus N2? Okay, so here if I write the number of moles equation, what is that? PV by RT relation that we are having, right? So here, if I write that relation for here, what will be final volume? What it is? It's nothing but what? V1 plus V2 only, correct? Final volume is V1 plus V2, correct? V is equal to what you can write? V1 plus V2. We can actually write temperature. We are taking it same only, right? So here, let's take initial pressure here P1, here pressure P2, right? So now the final number of moles, we can write it as what? From this relation, N is equal to PV by RT. We can write it as what? P, which is the final pressure, into the final volume is actually V1 plus V2 only, divided by R into T. That will be equal to what? Initial pressure P1, V1 divided by RT, right? Plus P2, V2 divided by RT we can add. So what will happen here? RT, RT, RT. RT cancels off. You have the final pressure. What is that? Equal to P1 V1 plus P2 V2 divided by what is that? V1 plus V2. Very simple relation here, right? So just now what we need to substitute all these values, we put it up, right? What is the initial pressure that is given? P1 is given as what? Yeah, P1 is 1 atm, P2 is 2 atm, correct? So the initial, all those values are also given. Initial volumes, also we have taken 2 liter, 3 liter, just we need to substitute. What will be the final pressure here? P1 is 1 into what is V1? V1 is 2 liters, correct? Into, sorry, plus P2 is what? 2 atm into 3. See, why didn't I convert this liters into meter cube? Why didn't I convert? Because in denominator it is also coming. That common unit will get cancelled. So you'll be getting 2 plus 3. So what is this equal to? 2 plus 6 divided by 5. How much is that? 2 plus 6, 8 divided by 5. What is 8 by 5? 1 time, remaining 3 in 36 times. So what you're going to get? 1.6 atm is the final pressure that you'll be getting. So option 2 will be the answer for this. And now question number 30. A particle of mass m is moving around the origin with a constant force F pulling it towards the origin. What is it? We have a particle of mass m. This is pulled towards the origin. It is in a moving around the origin, correct? This is the origin we are taking by a force F. If Bohr model is used to describe its motion, the radius r of the nth orbit and particle speed v in the orbit depends on n half. That is what. Okay. So how actually we can do this? We apply Bohr's quantization principle and we also apply the centripetal force relation. This force is providing the required centripetal force for the particle to be in the circular motion. Correct? So we can write to the first equation mv square by r. If the velocity, the linear velocity of this particle, if it is v, if I'm taking r is the radius of this orbit, if I'm taking mv square by r, you can write it as what f, that constant force f. Correct? And we also write the Bohr quantization principle. What is the Bohr quantization principle? We have MVR, correct? We have MVR, which is the angular momentum, which is NH divided by 2 pi. Okay, so if we club these two, we will be getting this very easily. From the second equation, if I write V, what would that be equal to? NH divided by 2 pi MR, you can write. And this, if I'm going to substitute in this equation, you get what? M by R into V square is what? N square H square divided by 4 pi square m square r square, correct? So here what will be happening? One m will get cancelled. And this, yeah, so here we have this is equal to what? F. Yeah. So here this will be giving you n square h square divided by 4 pi square m r cube you will be getting, correct? R square into r. That is equal to F. So what we are going to see here it is r cube that is proportional to what? N square, right? From the equation that we have got, what we can write? R cube, if I'm taking to right hand side, r cube is proportional to n square or r proportional to n to the power 2 by 3, correct? Taking the cube root on both the sides, you'll be getting r proportional to what? N to the power 2 by 3, right? So this is obviously from this itself directly you can write option number 3 will be the correct option. Let's check even the case of velocity also. How we do this in the case of velocity? We have the relation mvr or v, what we have got? V is equal to what? Nh divided by 2 pi mr. So V proportionality, if I'm writing it is N by R, you can write, correct? H and M will be constant only here, correct? So R proportionality already N to the power 2 by 3 is, so V proportional to N divided by N to the power 2 by 3. So V proportional to what? N to the power 1 minus 2 by 3 will be coming, or V proportional to N to the power 3 minus 2, 1 by 3. So your answer very clearly here, you can see N V proportional to what? N to the power 1 by 3 only. Okay, so we reassure this. Question number 30 is having answer option 3, right? Well, here is question number 31 now. The radius of Martian orbit around Sun is about 4 times the radius of orbit of Mercury. The Martian year is 687 Earth days. Then which of the following is the length of 1 year on Mercury is the question here. Okay, so this we can apply directly with what the law of periods in the case of gravitation, correct? Which is nothing but what? T square proportional to what? R cube, correct? Where T is the time period, R is the radius of orbit of this. Okay, so if we are going to apply, let's take Mercury, let's take Mars as, let's say, 1. Okay, Mercury, I'm going to take it as 2. Okay, so from this proportionality, T square proportional to R cube, we can write what? T2 by T1 the whole square. That is equal to what? R2 by R1 the whole cube, right? Or T2 square, what is that equal to? T1 square into R2 by R1 whole cube. It is given that the radius of the Martian orbit is 4 times that of the Mercury, correct? So it is R1, you can write it as what? 4R2, we can write. So this relation becomes equal to what? T1 square into R2. R1 is 4 times. So this you can write R2 by 4R2, correct? Whole cube. Okay. Or now if I'm going to take a root on both the side, you get 2 T2. What is that equal to? T1 into, you're taking square root. So to the power 3 by 2 it will be coming. So it will be like 1 by 4 cube, 4 to the power 3 by 2, or 4 cube whole to the power 3 by 2. Or you can write this as what? In simple terms, T1 into 4 cube is 64, right? 4 4 is 16 into 4 64 whole to the power half it will be coming, which is nothing but what? T1 by 8. Now, what is T1? T1 is that of the Martian year 687 Earth days. So T2 you can write it as what? 687 divided by 8. How much is that equal to? 8. 64, remaining 47, 6 times, sorry, 5 times it will go, correct? Remaining 7 in 70, again 8 will come. Remaining 6 will come. So whatever it is, you approximately you get this is equal to what 86 days is what you the Earth days is what you're going to get the answer to be. Okay, so when you check out the options of this, the closest one is actually 88 Earth days. So let's take this as the option. Option number one will be the answer for this. Well, the next question, question number 32. A body weighs 48 Newton on the surface of Earth. The gravitational force experienced by the body due to Earth at a height equal to one third the radius of Earth from its surface, what it is. Okay, this is actually, you can see here, the question is, what is the gravitational force experienced by the body due to Earth? Correct. What is the difference between that that is the gravitational force experienced by the body and the weight? Nothing. They both are the same, right? So what is the weight of the body at a height that is equal to one third the radius from the surface of Earth is the question. Okay. What we can apply here directly, the variation of acceleration due to gravity with the height. Okay. We have both these relation, right? How acceleration due to gravity varies. G dash is equal to what? G r square divided by what? R plus h the whole square, right? This is how, what actually the exact relation. We know, can we apply this relation? G dash is equal to G into 1 minus 2h by r relation. Can we use this? No, we can't. Because here the height is actually comparable with the radius. So we should not be using this relation. We should use this relation. So let's see the acceleration due to gravity, what it is. H, G dash is equal to what? G into r square divided by r plus. What is h equal to here? H is given as r by 3. So r by 3 the whole square. So what is that it will be giving you? G into r square divided by 3 plus 1, 4. 4r divided by 3, the whole square is what you'll be getting. Correct? So here you'll be getting what will happen here? G into r square divided by, right, 4 square, it is nothing but 16, and 3 square is nothing but 9. So 9 will come onto numerator here. We have r square cancels. So you have 9 by 16g. That is what g dash you'll be getting. So if I multiply on both the sides with the mass, you get what? Mg dash, that is equal to what? 9 by 16, correct? 9 by 16 mg, right? Mg is given as what? 48, correct? This is nothing but the weight of the body, which is given as what? 48 Newton. So you can write 9 by 16 into 48, correct? This is actually this mg dash. What is it? This is nothing but the weight that is required for the body, correct? So you will be getting 16 will go 3 times in this. 9 threes are 27 Newton will be the answer. So the weight of the body at a height that is equal to one third the radius. What is that equal to? 27 Newton. So option number 2 will be the answer for this. So yeah, question number 33. A wire of resistance R is cut into 8 equal pieces. From these pieces, two equivalent resistances are made by adding 4 of these together in parallel. Then these two sets are added in series. What is the net effective resistance of the combination? Simple question, right? Now, what we have to use in this case, the concept of combination of resistors, correct? Where if n resistors, suppose if they are connected in series, we have rs, you can write it as equal to what? R1 plus R2 plus etc., right? You just add all these resistors together. If they are in parallel, what you'll do? 1 by Rp, that is equal to what? 1 by R1 plus 1 by R2 plus etc. If two equal, I mean, like two resistors only means the parallel resistance, you can write it as what? The equivalent resistance R1, R2 divided by R1 plus R2. This is what. Okay, so here we are having a wire whose resistance is R. Now this is cut into how many equal parts? 8 equal parts you're cutting over to. Correct. So the resistance of each part, how much it will be? R by 8, R by 8, like that it will be. Now what you are doing? You are making two equivalent resistance by adding these by adding 4 of these together in parallel. So what you are doing? 4 of this you are taking, right? And you're connecting and making them in parallel like this. So it's like we have R by 8, R by 8, okay, R by 8, R by 8. 4 are actually in parallel with each other, right? So if you connect 4 in parallel, we know if n equal resistors you are connected in parallel, the equivalent resistance will be what? R by n, correct? So the equivalent of this section, how much it will be? That 4 you're connecting in parallel, R by 8 divided by 4 it will be. So that will be equal to what? R by 4 eights are 32, correct? That is what. So you have like this one more section, correct? So now it is like you're connecting these two sections, correct? You have this is actually the second section, right? Same. This resistance equivalent also how much? R by 32 you will get. So now it's like these two resistances, set of resistances, whose resistances are R by 32 and R by 32, you are connecting in series like this. Correct? That's what then these two sets are added in series. You're connecting them in series like this. So the equivalent, what it will be? Here it is 32. So the equivalent, how much it will be? We know now, we just have to add these two together. Okay. The R equivalent, you can write it as equal to what? R by 32 plus R by 32, which is like a 2R divided by 32, which is R by 16 ohm. Correct? Not in ohm. Yeah, sorry. R by 16 is what you'll be getting. So your answer will be option number 3. That will be the answer. Question number 34. De-Broglie wavelength of an electron orbiting in the n equal to 2 state of hydrogen atom is close to. All right. What is that atom chapter? The de-Broglie hypothesis we need to apply here, right? What is the de-Broglie hypothesis here? We have the de-Broglie hypothesis n lambda that is equal to what? 2 pi r. That relation directly we can use here. Correct? Rn, nth orbit if you are taking. Right? What is the nth orbit relation? Rn, that is equal to what? N square R naught, where R naught is the Bohr radius. You can actually tell that is the radius of the first orbit. Correct? So here we'll be getting this relation 2 lambda that is equal to 2 pi into n is like n square R naught. Correct? So 2 cancels off. You get lambda is equal to pi into, you have n is nothing but 2. So 2 square into R naught. Right? So what will be, this is what your question is, right? To find the de-Broglie wavelength, correct? Lambda. So you can write 3.14 into 4 into what is R naught? R naught is nothing but 0.052 nanometer. So what is that we'll be getting? 3.14 into 4 into this, what it is? 8. 5 was that 20, 0, 2, right? 0, 2, 0.208, this much nanometer. Now, how do you get this? You have to do the multiplication 314 into 208. Let's do how much it is. 2, 3, 11, remaining 1, 25, 0. Like this part will go 0, so 0. 4 to 0, 8. 2, 3 to 6. So what is that? 2, 1, 3, 5, 6. Now how many points are there? 0.208 is, so 3 plus 2, 5. So you'll be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So you'll be getting how much? 0.653. Like that, it will be coming the answer, this much nanometer. Okay. So the closest answer is, you can see 0.6967 nanometer. And there is much difference for the others. So you can take the answer to be what? 0.67 nanometer you can take, right? I think if you are going to take pi is equal to 22 by 7, little more exact value you'll be getting this. You can check it out. All right. Let's go for the next question now. Here we have our next question, question number 35. An electric dipole with the dipole moment 5 into 10 to the power minus 6 coulomb meter is aligned with the direction of uniform electric field of magnitude 4 into 10 to the power 5 Newton per coulomb. The dipole is then rotated through an angle 60 degree with respect to the electric field. What the change in potential energy of the dipole, right? So change in potential energy means what, right? The final potential energy minus the initial potential energy. That is the change in potential energy, correct? So initial potential, what is the relation for potential energy? We have minus P dot E, correct? Or PE cos theta, we can actually write. This is the potential energy equation. So initially, when how it is, the dipole is aligned in the direction of electric field. Okay, dipole moment and electric field in the same direction. So initial potential energy, you can write it as equal to minus PE cos 0, correct? And what is P given? Here P is given dipole moment, this is it. And the electric field magnitude, here it is given. So you can write minus P is 5 into 10 to the power minus 6 into what is E given? 4 into 10 to the power 5. Okay. Cos 0 is obviously 1 only you'll be getting, correct? Cos 0 is 1 only. So into 1. So how much is this? Minus 5 was that 20 into 10 to the power how much? Minus 1. So you'll be getting minus 2 joules is what the initial potential energy. Whatever the final potential energy? Final potential energy is again at minus PE cos, at what angle it is now with respect to electric field, this is rotated through an angle 60 degree vector P. Correct? So cos 60 it will be coming. So minus PE already we have seen. The magnitude is 2 only, no? Into cos 60 is 1 by 2. You'll be getting minus 1 joule is what you'll be getting. Right? So the change in potential energy, how much it is? Minus 1, right? Yeah, sorry. Here you can write minus 1 minus 2. correct? So what is that? We'll be getting minus 1 plus 2, which will be nothing but 1 joule. So the change in potential energy equal to 1 joule, 1.0. You can take it. Option 2 will be the correct answer for this. So here we go, question number 36. A constant voltage of 50 volt is maintained between the points A and B of the circuit shown in figure. The current through the branch CD of the circuit, what it is? All right. So this question is actually a very straightforward, simple question. Okay, where effectively we are considering the parallel combinations, the series and parallel combinations, basically. Together with that, the potential relation along the parallel branches. Okay, we might have to find some of the currents in different branches also. So let's actually start doing this step by step. Okay, so here first, what we are going to do, we analyze the circuit, we find the total current in the circuit. Okay, so if we are analyzing in this way, see this branch CD is actually the short between actually the top branch and the lower branch, correct? So obviously this 3 ohm and 1 ohm are actually in parallel to each other. At the same time, 2 ohm as well as 4 ohm are also in what? Parallel, correct? So their equivalent first we'll find, and these two will be actually in series with each other. Right. So we know how to find the equivalent for a parallel combination of two resistors. What is that? R1, R2 divided by R1 plus R2. Correct? This is the relation. So here we find if suppose let's consider three as well as one are in parallel. Three parallel with one. The equivalent will be what? 3 into 1 divided by 3 plus 1, which is actually what? 3 divided by 4, which is, yeah. So this much ohm, correct? 3 by 4 ohm. That is the resistance of that. At the same time, 2 is also parallel with what? Uh, 2 is in parallel with 4. So equivalent, we can find it 2 into 4 divided by 2 plus 4, right? How much is that equal to? 8 divided by 6, which you can write it as what? 4 divided by 3, right? So here we have these two. So now those two are actually in series. Which two are in series? So our circuit is now like this, right? This is actually the point C and D. You can connect it together. So here we have 3 by 4 and here we have 4 by 3. So those two are in series. Our circuit is now simplified to this, correct? So here we have 50 volt, right? And these two are the points A and B. So now we can find the equivalent of the circuit resistance. How do you find? These two are in series. So for series, we can find it as just by adding these two R1 plus R2. Correct? So here it will come as equal to what? 3 by 4 plus 4 by 3, where you may take 12 as the LCM. So here what will happen? 3, so 9 plus, so here will come 4 4s are 16. So you'll be getting how much? 25 by 12. So it's very clear here now. You can find the total current in the circuit, correct? Where we are finding the total current, I. How much is the total current? The total EMF, you can write it as 50 divided by the equivalent resistance, which is 12, 25 by 12. So you can write this as 50 divided by 25 into 12. Correct. So here what will happen? This will be 2 times. So 12 into 2, which is nothing but 24 ampere. So the total current in the circuit is how much? 24 ampere. Now see here what I'm going to do. I'll find, let's take like the current through the top branch here. Let's take it as I1. Okay, see, we have the parallel combination like this. Which combination? This 1 ohm and this 3 ohm. 1 ohm, 3 ohm parallel combination. The total current was like a 24 ampere. Let's take the current through the top branch is I1. So that through the lower branch obviously will be what? 24 minus I1. Kirchhoff current rule we are going to apply. Now since they are in parallel, 1 ohm and 3 ohm, the potential across both will be same. The potential across the 1 ohm will be equal to potential across 3 ohm because they are connected in what? Parallel. Now how we write the potential across that? I1 into 1 ohm, that will be equal to what? 24 minus I1 into what? 3 ohm. Clear now? So now how do you simplify this? I1 that is equal to 24 3s are 3 4s are 12, remaining 1, 3 2s are 6 plus 1, 72 minus 3I1. Correct. So now this 3I1, if it comes to left hand side, you will be getting how much? 3 plus 1, 4I1, that is equal to what? 72. Very clear. So here we can find now I1. How much is that I1 equal to? I1 is nothing but 74 divided by 4. Right. How much is that equal to? One time it will go in 34. Sorry, 72 it is, right? Not 74. So here, yeah, 74, 72 divided by 4. How much is that? One time it will go remaining 32 8 times. So the current through the top branch, how much is that equal to? 8 ohm, correct? Sorry, 18 ohm. sorry. So 18 ohm is the current through the top branch. That's what we are getting here. Correct. Now at the same time, what we can do, the total current through the second branch, which is this loop also, that is 2 ohm and 4 ohm. The total current actually through that, how much it is? Again, it is nothing but 24 ohm only. Sorry, 24 ampere only. Right. So again, what we do the same thing here. Let's take here the current is I2. So here the current will be obviously what 24 minus I2 we can take. We apply the same thing here. The potential across the 2 ohm that will be equal to potential across what 4 ohm. Right. Potential, how do you find again? You can across the 2 ohm resistor, you can write current through that is I2 into that resistance, which is nothing but 2 ohm. Correct. That will be equal to what 24 minus I2 into that is 4 ohm. So here obviously it will come what? Yeah, we can simplify this. This 2 and 4 you can cancel. It will be becoming 2. So here we get I2 that is equal to what? 24 minus I2 into 2. Or you get I2 that is equal to 48 minus 2I2. Or you get 3I2. What is that equal to? 48. You get I2 is equal to what? 48 divided by 3, which is 16 ampere. So what we are seeing here, I2 is equal to what 16 ampere. So now you see this branch, we had this 1 ohm, right? This is that point C, correct? And here you have this 2 ohm. The current through this 1 ohm was 18 ampere, correct? And the current through this 2 ohm, how much it is? 16 ampere is what we got. So what will happen to the remaining current? We know that it is 2 ampere current, which is nothing but 18 minus 16, which is equal to 2 ampere. This current actually flows through what? C. Correct? That's how we reach to the answer for this. The correct option is 2 ampere. Option number 2, 2 ampere will be the correct option for this. So here is question number 37. A photon and an electron of mass m have the same energy E. The ratio lambda photon to lambda electron of their DeBroglie wavelengths. So again, this is a question which is quite straightforward. We know the DeBroglie wavelength of a particle. What is that? H by P. H is the Planck's constant. P is the momentum, linear momentum of the particle. In terms of energy, if you are writing h by root 2 me, where E is the energy or the kinetic energy of the particle. The momentum of a photon, if E is the energy of the photon and C is the speed of light, you can write its momentum as what? E by C, correct? So obviously, if I'm writing the momentum of photon, lambda p, sorry, the wavelength of photon, if I'm writing lambda p, what would that be equal to? H divided by momentum is what? E by C. That of electron, if you are writing h by root 2me. Very clear now? So directly we can find lambda p divided by lambda e, which is nothing but hc by e divided by h by root 2me. Correct? So here reciprocal multiplication, if you are doing hc by e into what will that be? Root 2me divided by h. What will happen here? Obviously, h and h will get cancelled. If E you take it inside the root, you will get what will that be? Root 2me divided by E square. Correct? One of the E will get cancelled. You get C root over 2m by E. And that's the ratio of this lambda photon to lambda of electron that you'll be getting. And the answer will be C root 2m by E, option number 3. All right. Question number 38. Which of the following options represent the variation of photoelectric current with the property of light as shown on the x-axis? So on the y-axis, we have photoelectric current. In the first option, it is with the intensity, second also with intensity, third and fourth with the frequency. Again, a quite simple, straightforward question. Okay, the first option, is it right or wrong? Photoelectric current is proportional to intensity, correct? That is actually an observation of photoelectric effect only, correct? And you can explain it like this. Right? More intensity means more number of photons. So more number of photoelectrons will be ejected and obviously photoelectric current will be more. So obviously option A is correct. So very clearly option 2 is actually wrong. Correct? It's not photoelectric current will not be constant. Third one, what it is, with the frequency, will the photoelectric current increase? No, it will not increase. Why? Because the photoelectric current is proportional to intensity only. Frequency, what is it deciding? It decides the energy, correct? The maximum kinetic energy of the ejected electron, right? Frequency is more means only changes photons will have more energy. So the electrons that are ejected comes out maybe with the kinetic energy, which will be more. Correct. So it does not affect what the number of photoelectrons that is emitted. So these two options will not be correct. So the correct option will be option 1, which is A only, will be the answer for this. Question number 39. We have a sphere of radius capital R is cut from a larger solid sphere of radius 2r as shown in the figure. The ratio of moment of inertia of the smaller sphere to that of rest part of the sphere about y-axis, what it is the question. Again, a classic, very important question from moment of inertia, correct? Where we'll be asked to find basically the moment of inertia by applying basically what the parallel axis theorem. It's actually a very simple problem, okay? Removal of mass problem only. So how to do this? Let's see. Okay, what are the two things of which you want to find the ratio of moment of inertia? That removed part, you need to find the moment of inertia that you divide with what the remaining part. So let's identify what are the moment of inertia of these two, correct? So for that, let's identify first the moment of inertia of that smaller sphere that is removed and that complete sphere, right? Including the, I mean, if the mass is not removed, what will be the total moment of inertia? Okay, so these two will find, and then the removed portion will find, and then we can find the ratio. All right, so very clear. Okay, so here, so the basic property of this, what it is, if suppose we have a mass m, let's say we have a mass m, correct, or m1 with respect to an axis, if this particle is revolving, right, its moment of inertia, you can write it as what, if at a distance r1, correct, so it will be m1 r1 square, correct. If one more mass is there that you are seeing, which is at a distance r2, that is also revolving together with this at the same angular frequency. This 2 as a system, if it is rotating, you just add this thing, correct? M2 R2 square. So if one of this you are removing, you just have to do what? That part, what is the moment of inertia that you subtract. That's what you will be effectively doing in this case. Okay, so that principle only we are going to apply here. So if the smaller sphere, if you are taking, we have it is of radius what? The small sphere, we have it is of radius what? Capital R. Okay, so if suppose, see, first let's need to understand, or we need to have a relationship between the masses of these two, smaller sphere and the bigger sphere. So smaller sphere, if you are taking the mass m, how much will be the mass of this? You can write mass is nothing but volume into density. So you can write 4 by 3 pi r cube, radius is r, into density rho. Okay, we are taking these two spheres are actually uniform mass density it is having. So at the same time, if you are taking the larger sphere, right? Larger sphere, if you are taking its radius, how much it is 2r. So its mass, if you are taking m dash, how much that will be 4 by 3 pi 2r the whole cube into rho. So 2 cube is nothing but what? 8 it will be coming. So 8 into 4 by 3 pi r cube rho. So you'll be getting what? 8 times the mass of the smaller sphere is that of bigger sphere. Correct? Very simple. So now let's find what is the moment of inertia of this smaller sphere. See, we know if you have a sphere with respect to an axis that is passing through its center of mass, the moment of inertia is nothing but what? 2 by 5 mr square, right? R is the radius, m is the mass, right? So by applying parallel axis theorem, I need to know what is the moment of inertia with respect to this y-axis, which is actually coming as a tangent, right, to the sphere. So you can apply very clearly the parallel axis theorem, which is nothing but I naught plus m. What is the separation between these two? The perpendicular distance between these two axes is also r only, so you'll be getting mr square only. So it will be very clearly 2 by 5 mr square plus mr square. All right. So how much that will be equal to? 5 plus 2, 7 by 5 mr square is what you'll be getting the moment of inertia of the smaller sphere. Correct? With respect to what? Y-axis. Right. Let's mark it as, let's say, I1, I'm marking it. So this is the moment of inertia of that smaller sphere with respect to y-axis. So if I'm taking now the moment of inertia of the bigger sphere, correct? I O dash, if I'm taking, that is the moment of inertia of the bigger sphere, if the mass is not removed, okay, you can write it as what? 2 by 5 into its mass is nothing but 8 times the mass of the smaller sphere. So I'll write 8m into its radius is what? 2r the whole square, correct? Where 2 by 5 mr square only we have applied here. So you'll be getting what? 8 2s are 8 2s are 16, 16 4s are, or yeah, what you can write? 18 to 16 into 4, right? 16 into 4 is obviously 64. 64 by 5 mr square is what we'll be getting very clear. So if I find the moment of inertia of that bigger sphere after removing that smaller sphere from that I'm marking I2. What will that be? Like in the problem that we have seen at the beginning, you just remove the mass of that, the moment of inertia of that removed mass. So you'll be getting what? This is nothing but I naught or I o dash, which is the moment of inertia of the complete bigger sphere minus the moment of inertia of that smaller sphere that is removed. So you'll be getting what? This is 64 by 5 mr square minus here it will come 7 by 5 mr square. So here you'll be getting 64 minus 7 is obviously 57 by 5 mr square. So this is the moment of inertia of the bigger sphere with the mass that is removed. So you just have to find out the ratio, which is nothing but the moment of how you want to find this moment of inertia of the smaller sphere to that of the rest of the sphere about y-axis. So answer is very clear here. I1 divided by I2, which is nothing but what? 7 by 5 mr square divided by 57 by 5 mr square. What will happen here? Mr square cancel, 5 cancels. You'll be getting 7 divided by 57, and that is going to be your answer 7 by 57, option number 3. All right, question number 40. A Fourier rectifier circuit with the diode D1 and D2 are shown in figure. If input supply voltage Vin is equal to 220 sine 100 pi t volt, then at t is equal to 15 millisecond, what will be the state of these diodes? D1 is forward bias, D2 is reverse bias. D1 is reverse bias, D2 is forward bias. D1 and D2 both are forward bias, D1 and D2 both are reverse bias. Which of this will be the correct option? Okay, so here, how we can approach this question? Very simple thing. At t is equal to 15 millisecond, right? At t is equal to 15 millisecond, what will be uh, the potential will identify, right? The input potential, correct? So what will be coming that across the secondary of the transformer will identify that, right? So the basic thing that you need to keep in mind here, what it is, there will always be a 180-degree phase difference or pi phase difference between what? Between the primary and secondary of a transformer. Okay, so this effectively you should keep in mind. Between the primary and the secondary of a transformer, there will always be a 180-degree phase difference or pi radian. There will be a phase difference. Okay, so we'll first find we have it is given the input potential. How much is that? 220 sine 100 pi t. So let's say which cycle is going on? Is it the positive half cycle or the negative half cycle of the input cycle? Will identify. Okay, at t is equal to what? 15 millisecond. At t is equal to 15 millisecond, if I'm applying V in, what would that be equal to? 220 sine, okay, 100 pi, correct? Into t, what it is? T is, we have 15 millisecond. So 15 into 10 to the power minus 3, right? 15 into 10 to the power minus 3. So how much is that? Will be giving you 220 sine, correct? See here, these two zeros and this, if you are taking off, you'll be getting what? 10 to the power minus 1, correct? This is 10 to the power 2, and this, if you club with this, you get minus 3 plus 2, which is minus 1. That 10 to the power minus 1, you can bring to denominator what you're going to get. 10, sorry, here 15, correct? You'll be getting 15 pi divided by 10, correct? 15 pi divided by 10 is what you'll be getting. And if you simplify that, you'll be getting what? 3 by 2. So this is 220 sine 3 pi by 2, correct? And what is sine 3 pi by 2? Sine 270. How much is that equal to? It is minus 1 basically, correct? So what you're going to get? Minus 220 volt is what you'll be getting. So you need to keep in mind it is a negative. It's actually the ongoing cycle is actually the negative half cycle of this. So obviously when it comes to the secondary of the transformer, it will be 180 degree phase difference also you need to see. So obviously what will happen? This negative, it becomes what? Positive. So obviously you can take like that across D1, if you are taking the diode D1, like the positive potential, and across this, the current will be flowing like this from D1 across. I mean, it will be like the positive P side of this D1 will be connected to the positive potential, N side will be connected to the negative potential. But the case of D2, it will be like the P side connection connected to the negative potential, N side connected to the positive potential. So obviously you can tell like D1 is forward biased and D2 is reverse biased will be the answer. You can take like option 1, D1 is forward biased, D2 is reverse biased. We can take it as the answer for this. So now question number 41. Two gases A and B are filled at the same pressure in separate cylinders with movable pistons of radius RA and RB respectively. On supplying an equal amount of heat to both the systems reversibly under constant pressure, The pistons of gas A and B are displaced by 16 centimeter and 9 centimeter respectively. If the change in their internal energy is same, then what is the ratio of RA to RB is the question. Again, this is also a straightforward question only where we use the first law of thermodynamics. What is the first law of thermodynamics? We have delta Q is equal to what? Delta U plus delta W. What is it given in this case? You can see that equal amount of heat is given to both the systems. Correct? Equal amount of heat is given. So delta Q is same. And if the change in internal energy is same, that is a condition given. So delta U is also what? Same. So obviously for the two systems that you are seeing, correct? This is of radius Ra, the first cylinder, right? And you have the second cylinder, you have of radius what? Rb. This is connected with the pistons as they have told, correct? So in the first case, what is it? At a constant pressure P, this will move up, Ra move by a distance 16 centimeter. This will move by a distance of what? 9 centimeter. So since heat supplied and change in internal energy is same, what you can tell, the work done also will be what? Same, right? So delta WA, that will be equal to what? Delta WB, we can actually write. Now what is work done? At constant pressure, you can write P delta V in the case of cylinder A, then P into delta VB in the case of second one. So P pressure also will get cancelled off. The change in volume, what it is radius is not changing, it is the length of the cylinder that is changing, correct? Because the piston is moving, correct? So here we can write what? The area of A cylinder into the length of A, correct? That is the change in length. We can mark it as change in length of A, correct? Because volume is nothing but what? Area into length, base area into height of a cylinder. So change in volume, here area is not changing. So A delta L we can write. So this will be equal to what? AB delta LB. Very clearly we can write. So now what we can do, this area is nothing but what? Pi r square, correct? A is pi r square. So in the case of A, this will come RA. In the case of B, RB. So pi, we can actually cancel on both the sides. We can write what? RA square into delta LA. That is equal to what? RB square into delta LB. All right. So here what is that we need to find? RA by RB only. So what we do? RA by RB the whole square. What will that be? Delta LB divided by delta LA. Very simple now. So what is delta LB? Change in length in the second case is 9. So you'll be getting 9 by 16. Correct. So here RA by RB, if you are now finding, you have to take root on both the side. You'll be getting what? 3 by 4. And that's the answer for this option number 2. 3 by 4 will be the answer here. Let's see question number 42. A physical quantity P is related to four observations A, B, C, and D as follows. P is equal to what? A cube B square divided by C root D. The percentage errors in the measurement of A, B, C, and D are 1, 3, 2, and 4% respectively. The percentage error in the quantity P, how much it is? Correct. Again, a simple, straightforward question only. Multiple times this question has been asked. Very important type of question in NEET, right? It is given that we have this quantity P is related to four quantities like this. Then the percentage error in P, how much is the question? We have the fractional error delta P by P, correct? What is fractional error? Delta P by P. You can write it as equal to what? Since the relation is, it is proportional to what? A cube, you can write it as 3 delta A by A plus 2 delta B by B. You will take in the case of C as positive or negative, you have to take it as positive only, correct? Even though it is in the denominator. Plus delta C by C, because C to the power 1 it is coming. What about the power of D? D to the power minus half it is. So whatever be the positive or negative, you have to take it as plus only. You'll be getting what? 1 by 2 delta D by D. Very clear now. So if I'm seeing now the percentage error delta P by P into 100, what does that be? 3 delta A by A into 100 plus 2 delta B by B into 100 plus delta C by C into 100 plus half into delta D by D into 100. Right? So this delta A by A is the percentage error in A. How much is that? 3 into, in A it is nothing but 1% plus that in the case of B, how much it is? 2 into 3%, correct? In the case of B, it is 3%, right? So plus in the case of C, it is 2%. So 2, correctly directly, plus half into, in the case of D, it is 4%. So into 4 will come. So how much it has? 3 plus 6 plus 2 plus 2. 4 by 2 is 2. So how much is this? 6 plus 2, 8 plus 2, 10 plus 3, 13% is what will be the percentage error in P. Option number 3 will be the correct option here. So here is question number 43. The intensity of transmitted light when a Polaroid sheet placed between two crossed Polaroids at 22.5 degree from the polarization axis of one of the Polaroid, okay, is how much? It's given that I naught is the intensity of polarized light after passing through the first Polaroid. What is that thing? Here we have two Polaroids which are crossed. Okay, the angle between these two is pi by 2 we are taking. Now you're placing in between one more Polaroid sheet you're placing such that with any one of it, it is making 22.5. Let's take the first one is with the first, second, and third. Between first and second, it is 22.5. Let's take. Okay. See, 22.5. What is 22.5 basically? It is 45 by 2, which is nothing but pi by 4 by 2. So it will be like what? Pi by 8, correct? Correspondingly, you can write this as what? Pi by 8. So this angle is pi by 8. So this will be obviously pi by 2 minus pi by 8. Very clear. Correct. So what will be the final intensity is what we need to find. Sorry. What will be the final intensity? Okay. So how do you get after passing through the first, it is I naught. Correct. That is given in the question. So here you need to note that after passing through the first, it is a plane polarized wave only. Okay. Now if that passes through the next Polaroid, okay, or see a normal consideration is that you're going to take it like you may take it as like what I naught by 2. Don't take it like that because it is already plane polarized. Okay, so you need to consider in that case, in that case also we need to apply Malus law. And how much will be that after passing through the second? Okay, after passing through second Polaroid, you can actually take the intensity. If I'm taking here, it is I1, let's say. What will be I1? That will be equal to I naught. That is the one intensity before passing through the second. Cos square. What is the angle between first and second? That is nothing but 22.4, which is nothing but pi by 8. Okay. So how do you get this one now? Cos square pi by 8. How do you get? Or let's keep it like that only. I not cos square pi by 8. Okay. After finding the final one, let's substitute this one. Now after passing through the third, what will be the intensity? If I take it as I2, what will that be? You have I1, that is the intensity before passing through the third. So that is I1 cos square. See, I1 cos square. What is the angle between second and third now? It is pi by 2 minus pi by 8. All right. So here, what will this be equal to? What is cos? So this can I write it as I1 cos pi by 2 minus pi by 8, right? This whole square. Now, what is cos pi by 2 minus pi by 8? It is simply sine pi by 8 only. So this you can write I1 sine square pi by 8 you can actually write. Or this you can write it as what? What is I1 we have got? It is I naught cos square. So I naught cos square pi by 8 into sine square pi by 8 we can actually write. It's simplified it to a very simple case now. So this you can write it as equal to what? I naught, correct? Cos pi by 8 sine pi by 8 the whole square we can write. Correct? What is cos pi by 8? What is or cos x into sine x? See what we do? We use this identity here. What is that? Sine 2x. What is that equal to? Sine or sine 2x. What is that equal to? 2 sine x cos x. Correct? So this sin x cos x will be nothing but what? This will come to the left hand side. You can write sin x cos x, that is equal to what? Sin 2x divided by 2. Correct. So this whole square means what? Sin square 2x by 2 square will come. So obviously the term that we have written here in the bracket, you can write the final relation I2, correct? I2, this is I2. I2, how much is that equal to? I naught into, you can write instead of sine pi by 8 into cos pi by 8, you can write sine 2 into x is nothing but what here? X is what did we take? X we took it as pi by 8. So 2 into pi by 8, correct? Sine 2x whole square or sine square x divided by 2 square, what that is nothing but what 4. So here you get I naught into what is sine 2 into pi by 2? Pi by 8, sine pi by 4, correct? Sine square pi by 4 divided by this 4 is also there. So you'll be getting what? I naught by 4. What is sine pi by 4? 1 by root 2. So you get 1 by root 2 the whole square, which is nothing but 1 by 2. So you'll be getting I naught by 4 into 1 by 2. So your final answer, what will be? I naught by 4 twos are 8. So after passing through the third polaroid, the intensity that you'll be getting will be equal to what? I naught by 8. Okay, so your option will be what? Option number 3, I naught by 8 will be the answer for this. So write the next question, question number 44. Two identical point masses P and Q suspended from two separate massless springs of spring constant K1 and K2 respectively. They oscillate vertically. If their maximum speeds are the same, the ratio AQ by AP of the amplitudes AQ of mass Q to the amplitude AP of the mass P, how much is the question? Right? So what is that we are having here? You have two massless spring, correct? They are connected to two identical point masses. Let's point masses there. Let's take it as M. They are identical masses, correct? The spring constants of the spring are K1 and K2 also. Now, K1 and K2, they oscillate vertically. If their maximum speeds are the same, correct? What is the ratio of AQ by AP is the question here, correct? So what is actually the relation for maximum speed? We can write a Vmax that is equal to what? Omega A, correct? Velocity of an oscillating spring in terms of angular frequency omega root over A square minus X square. And where will be the max, the linear velocity, the velocity V maximum at the mean position, X equal to 0. At X equal to 0, we can write a V is equal to omega A. Correct? It's given that these two are equal also. This maximum speed is basically equal. So you can write what? Omega P into AP, that is equal to what? Omega Q into AQ. The question is to find AQ by AP. Correct? AQ by AP. So AQ by AP will be what? Omega P by omega Q. Now how to get omega value? Omega, the ratio of omega, how we can get? So this actually we have to go with what the angular frequency relation. We have omega is equal to what? Root k by m. Correct? Omega is equal to root k by m. Right. So if I find now the ratio here, we have omega. Omega is root k by m. So since mass is same, you can take omega is proportional to what? Root k. So if I'm writing here on the right side, what we have got just now, omega proportional to root k. So if I write omega p by omega q, what is that you're going to get? Root kp by kq, right? Kp is given k1 only, no? P and q, k1 and k2. So this you can write the root k1 by k2. So your answer will be what? Omega p by omega q is root k1 by k2 you'll be getting. And the answer of the ratio of the amplitudes of q and to that of p, aq by ap, what is that equal to? Root k1 by k2 is what you'll be getting. Option 4 will be the correct option here. The 20th question. This is on parallel plate capacitor. What is it? The plates of a parallel plate capacitor are separated by D. The two slabs of different dielectric constant K1 and K2 with the thicknesses 3 by 8 D and D by 2 respectively are inserted in the capacitor. Due to this, the capacitance become 2 times larger than when there is nothing between the plates. K1 equal to 1.25 K2. The value of K1, how much it is, right? You need to find. So we know this very clearly. If you have a parallel plate capacitor with separation between the plates D and area of the plate A, the capacitance is equal to what? Epsilon 0 A by D. When there is vacuum between these two plates, then there is no medium. Correct. But then if you are filling with a dielectric, okay, with a multiple dielectric if you are taking, right? For example, let's write it for a general case of you have a T1, T2, etc., Tn. Their dielectric constants are K1, K2, etc. So this becomes what? Epsilon 0 A divided by D minus, you add all the thicknesses of the dielectrics together. So T1 plus T2 plus etc. plus what will be happening? T1 by K1 plus T2 by K2 plus etc. Correct? This is the relation that we are going to use. And what is our starting point? It is given in the question. The capacitance become 2 times larger when there is nothing between the plates. So C dash is equal to twice the initial case. Right. So in our given question, what is that? We have a parallel plate capacitor. You have two dielectric, right? Almost d by two you're filling with the what K2. And you have a section of this whose thickness is 3D by 8. You're filling with the K1, right? So the capacitance of this, if I apply this in equation, what you're going to get here, epsilon 0 A divided by epsilon 0 A divided by. See here, this d by 2 and 3D by 8. If I'm going to keep it as the common base, that is 8. You have 3D by 8. D by 2, how you can write multiply and divide with what? 4. So you get 4D by 8. This will be easy to solve. Correct. 3D by 8 I'm talking of. So epsilon 0 A divided by, we have total D minus, you add these thicknesses together, correct? These two thicknesses together. So you have 3D by 8. D by 2 is nothing but what? 4D by 8. Plus T1 by K1. What is T1 again? 3D by 8 by K1 means by K1 plus D by 2, which is nothing but 4D by 8 K2, right? This is equal to what? Twice. You can write epsilon 0 A by D. So in every term in the denominator, you can see D is there. So epsilon 0 A will cancel. Obviously, the D also will get cancelled. And remaining, if I'm taking this in the reverse form, you'll be getting already D I cancelled, right? So 1 minus, in the bracket terms, that will be coming like 3 plus 4, 7 by 8 will come, right? Plus reverse you are taking. D already got cancelled. So you'll be getting 3 by 8 K1 plus 4 by 8 K2, correct? 4 by 8 K2. That is equal to what? 1 by 2 because we have taken inverse. So 1 minus 7 by 8 is nothing but what? 1 by 8 plus. Again, what you can do here, uh, yeah, what will be happening here? 3D by 8 K1 you have taken. 3D by 8 and plus. Okay, here, what we do here, it's also given this thing. What is that? K1 is equal to what? 1.25 K2. Okay, that step also we need to add. K1 is equal to 1.25 K2 or 1.25. I prefer to write actually in this multiple fractions are involved now. I think you can write that's what 5 by 4, correct? So you need to find K2, sorry, K1. So K2 is equal to what? 4 by 5 K1. So in place of this K2, you need to substitute what? K in terms of K1, we need to substitute. So 3 by 8 K1, correct? 3 by 8 K1 plus 4 divided by 8. What is K2? K2 you are having 4 K1 divided by 5. So this 4 get cancelled. This is equal to 1 by 2 obviously. So you get 1 by 8 if I take to the right hand side, you get 3 by 8 K1 plus 5 by 8 K1. That is equal to 1 by 2 minus 1 by 8 you will be getting. I'm writing the remaining things here. You'll be getting what? 3 by 8 K1 plus 5 by 8 K1 is nothing but what? 1 by K1 because 3 plus 5 is nothing but 8. So 8 by 8 K1 is 1 by K1 only. That will be equal to what? 8 if you take LCM. 4 minus 1. You'll be getting what? 3 by 4 minus 1. 3 by 8. So K1 is obviously 8 by 3. How much is that? 2 will go. The remaining 2 3s are 6. Remaining 2 is there. In 20, 6 3s are 18. So 2.66 is what you'll be getting the value of K1. 2.66 option number 1 will be the answer for this. So here we go to the last question, question number 45. What is that? A pipe open at both ends has a fundamental frequency F in air. The pipe is now dipped vertically in water drawn to half of its length. The fundamental frequency of air column, what is now? That is the question. Correct. So simple question. So here we have a open pipe, let's say. We have an open pipe. Correct. So now if this open pipe you're having, let's say its length is L. Correct. Now what you are doing, you have water and you're dipping half of its length in the water. So how much is outside water? L by 2 length is outside the water. Correct. So the point is, this was initially basically open at both ends, means it is an open pipe. Now, when you dip half of it in water, it became a closed pipe. Correct. So the fundamental frequency in both the cases. What is the relation for fundamental frequency? In the case of open pipe, we have F that is equal to what? We have V by 2L only. Correct. But in the case of closed pipe, what is that? Fundamental frequency is actually given by V by 4L. That is a fundamental frequency. Correct. Where L is the length. Correct. These two L's are different, obviously. While taking it into the problem, we'll just do it in that way. So it is very clearly given. F is the fundamental frequency in air, right? That is in the case of open pipe. So the first condition I take F is equal to what? V by 2L only. In the second condition, in the case of this water pipe that is dipped in water, it became now a closed pipe, correct? Because one end is now, you can see it is closed, right? Water is coming. So it's a closed pipe now. In the case of this closed pipe, you can write the fundamental frequency. We have what? V by 4L, correct? V divided by 4 into what is the length now? L by 2 only. So we have to write it as what? L by 2 we need to write. So this will be what? V by 4 cancel with it, cancel by 2. You'll be getting what? 2L only. So here we are getting this is equal to what the fundamental frequency in the case of open pipe only. So your final answer will be what? Option 2, that is equal to 4 only will be the answer.